Okay, everybody, get ready to do lesson 12.8 of pre-algebra math. Email me here, then we're going to do part 1. Email me for part 2. 12.8 sequences today, and then we have 38 points here for your class worksheet. Get that from me. I got a whopping 30 points here for your notebook taking. You can get a notebook taking guide from me as well. Arithmetic sequences and geometric sequences, we're going to get into that. And here's your standard up here. Today's spell work teachers, short response here. We've got a word problem, an interest problem here. Use the calculator to make a table. Students, make a table. And then how many years will the balance be greater than $1,700? That's your kind of like your constructed response there. And then down here we have multiple choice. For this function here, what is the value of y when x equals 4? Give your students 6 minutes, 7 minutes, teachers. Okay, welcome back for your solutions for today's bell work. And here's our table. What is that going to look like? Here is what it looks like on a calculator for number 1. So which year will be greater than 1,700? It looks like here year 6. Year 6 you have $1,800. Year 5 is 1683.1, so it's not quite 1,700. But year 6 it is, so it would be 6 years after. And then for number 2 it would be when x equals 4. You do this plug in here, and you have 2 times 625. You get 1250 for number 2, which is C. Okay, into our today's lesson. We wrote rules for graph functions. So we've wrote rules way back. You'll extend and graph sequences now. So graphing sequences is an ordered list of numbers. Each number in a sequence is called a term. One type of sequence is arithmetic. In an arithmetic sequence, the difference between the consecutive terms is constant. So we have a difference here. So here is a key word, difference. This difference is called the difference for an arithmetic sequence. So an example here of an arithmetic sequence is provided here. So for position number 1, the term would be 4, for example. Then position number 2, we have a 7. So what's the difference here between 4 and 7? And then for position number 3, we have 10. Again, the difference here is what? And then for position 4, we have 13. So you see the pattern here. And then for 5, we would have 16. So what's the difference here between 13 and 16? It should become apparent. So for that, 7 minus 4 would equal 3. So we have a difference here of 3, 7 minus 4. And then for 10 minus 7, it would be 3. And then for 13 minus 10, it would be 3. So you definitely see that the difference here would be 3 for each one of these. So since it's a constant here and it is a difference, it would be an arithmetic sequence here. So the common difference would be 3, as we've seen as apparently. So into an example here, extending arithmetic sequences, find a common difference for the arithmetic sequence, then find the next 3 terms. So here we have a sequence here, 12, 17, 22, 27, 32. Some of you probably already got it. We got a difference here of 5 is what we have. So, whoa, that would be number 5. So then the next 3 terms will be what? It would be 32 and 5, 37, 42, 47, etc. So you got 10 here between these two. You got 10 here between those two. You got 10 here between that. And then for B, 5, 3, 1, negative 1, negative 3. So what's going on here? So we have a difference here of negative 2. We're going backwards here. So we have a negative 2 here, a difference of negative 2. And the common difference would be negative 2. Next 3 terms will be here would be negative 5, negative 7, and negative 9. That would be the next 3 terms for this sequence here. Okay, find a common difference to this arithmetic sequence and write the next 3 terms. That's our guided students. This is your independent practice here. Find a common difference, then write the next three terms, okay? Pay attention so you can do yours. We're going to do number 1 now. Okay, so for number 1, 14, 12, 10, 8 is negative 2. If we have a difference in negative 2, next three terms would be what? 6, 4, and 2, 0, negative 2, negative 4, etc. So that would be your sequence there. And the ellipsis here means it just goes on and on and on. So, okay, definitions here, vocabulary. In your own words, students, sequence, define sequence, and define term. This is 10 points, students. This goes in your notebook. I check notebooks on Fridays. If you don't have them there, you don't get 10 points. That hurts. Okay, then we have arithmetic sequence. And then we have common difference here. Again, a 10-point entry here for your notebook. Page 6 on 12.8. Okay, so geometrics. We're going to move into geometric sequences now. Another type of sequence is a geometric sequence. The ratio of any term. Ratio here is a key word. Instead of difference, now we're talking about a ratio of any term to the previous term is constant. This ratio is called the common ratio. So instead of a common difference, we have a common ratio. That's the difference between arithmetic and geometry. So let's put this up into our little table here to see exactly what that is. So we have position 1 now, we have 3. And then for position 2, we have 6. So what's the common ratio between these two? Then for 3, we have 12. And then for 4, we have 24. Then for 5, we have 48. So what's going on here? 3 and 6, what's going on? 6 over 3 is 2. So here's our ratio. This makes this geometric instead of arithmetic. And then 12 over 6 is 2. Here's our ratio is 2. And then 12 and 24, our ratio is 2. And then 24 and 48, our ratio is 2. So what we have here is a common ratio is 2. We have a geometric sequence with a common ratio of 2. Okay, geometric sequence. In your own words, students, define geometric sequence and define common ratio. That goes in your notebook. I'll do notebook checks. I'm telling you, I will. Extending geometric sequences, find a common ratio for the geometric sequence and find the next three terms. So here's a geometric sequence here. Find the next three terms. So how will we do that? We have our ratio here is 3 between these two. 3 times 2, 3 times 6, 3 times 18. So what would be the next three terms here for this one? So it'll be 162, 486, and 1458. When you multiply these out here for the next three terms, here they are. And then for B, we have this sequence here. What's going on here? So we have a common ratio here of 1 over 2. So 1/2, multiply each one of these by 1/2. What would be our next three terms here, class, for these 1/2? So the next three terms would be 10, 5, and 2.5 for this geometric sequence here. Okay, our guided practice, tell whether the sequence is arithmetic or geometric. Then find a common difference or common ratio, write the next three terms. Same thing for you down here, students. So pay attention. And for our guided practice today, here is the situation here, 110, 1.1. So we're dividing here by 10 for each one of these terms here in the sequence. Common ratio is 1 over 10. The next three terms in the sequence would be 0.01, 0.001, and 0.0001. So that would be the direction that sequence is going. Down here, students, that's you, okay? And that's 12.8, part 1. Part 2 is available here. Test worksheets, quizzes, tutoring, you name it. Thank you.